Up until now, we've been looking at integration on its own, and you're probably thinking, what does this have to do with anything? Well, in short, when we find the definite integral of a function, we're actually finding the area under that function between the x values represented by the limits on the integral. Let's take a closer look. Say we had this super basic integral, the integral of x between 0 and 2. If we evaluate this integral, you'll see that it ends up as 2. Now, we said earlier that this integral corresponds to the area under the graph y is equal to x. We can verify that this is true by finding the area of the triangle that is formed by this graph and the x bounds. And as you can see, the area ends up as 2 units squared as well. You might be thinking, well, what's the point of integration? Why not just find the area under the curve by using a combination of different shapes? Going back to the first curve we saw, there's no way to easily and accurately find the area under this graph just by using shapes. Now let's take a look at an example to understand the difference between signed area and non-signed area. Say we had this integral here. As we can see from the graph, some parts are under the x-axis while some are above. If we perform this integral without taking this into consideration, the negative parts will cancel out the positive parts. This is what's known as signed area. This isn't an issue if we want to just calculate the integral. However, it is a problem if we want to find the area under a graph, since we don't want the negative areas cancelling out the positive areas. The solution is simple. We separately find the areas below the x-axis and take the absolute value of these negative values, and then we add it to the areas above the graph. In this case, the area above the x-axis is from x is equal to 0 to x is equal to 2, and the area below the graph is from x is equal to 2 to x is equal to 4. We perform these integrals separately, taking the absolute value of the area under the curve. Notice that we've expanded the brackets since we can't integrate the expression otherwise. The area above the x-axis is positive 4, and the area below is negative 4. Taking the absolute value of negative 4, our final answer for the area comes to 8 units squared. This is called unsigned area since we essentially ignore the negative signs. You can see that if we hadn't taken the absolute values, our area would be 0, which doesn't make sense because there obviously is area under the graph. These questions can be difficult since you'd need to work out which areas are under and above the x-axis. The best way to do this is to draw out a sketch of your function like we did for this integral, so you can see which parts are above and which parts are below the x-axis. In the next video, we'll be walking through an exam style question start to finish, so we can get a better idea on how to do these types of questions.